So hello students, welcome back to our channel. Today we are going to dive into the fascinating world of solubility. Get ready to become a master of solutions as we explore the basics of solubility, solute, solvent and the different types of solution. Let's get started. So what is basically solubility? So solubility is nothing but a when there is one substance called as a solute which dissolves in another substance called as a solvent, and by combination of this solute and solvent we get a solution. So solution is a homogeneous mixture of solutes in a solvent. So the word homogeneous is important. So what is homogeneous means? What is the meaning of word homogeneous? So homogeneous, there are two types of words. One is homogeneous and another word is heterogeneous. So what is exactly homogeneous means? So homogeneous here indicates that when two substances are mixed together, we cannot differentiate between these two substances. Like for example, if we mix milk and water, then we cannot differentiate with naked eyes which is milk and which is water. That is called as a homogeneous. And opposite of homogeneous is heterogeneous, where if you try to mix two types of substances, then we can see the two substances are not mixed together. That is called as heterogeneous. For example, if we try to mix oil and water, we will see two different types of layer containing one layer containing oil and another layer containing water. In such case, it will not be called as a solution. So solution is always homogeneous, where one substance which is also called as a solute completely gets mixed with another substance called as a solvent. So here is a one simple example of solution. If you add salt, sugar in water, then salt, sugar dissolves in water. So on daily basis, you might be encountering different types of solution. So one of the simplest type of solution is addition of salt in water or sugar in water. So on daily basis, you might be having a tea. So in for making a tea, we are dissolving or we dissolve uh, sugar in water. So that is one of the simple example of solution. Then next we will move towards the definition of solubility. So this was the formal introduction to the solubility, but we have to see what is the exact definition of solubility. So solubility can be defined in two ways. One is through qualitative way and one is through quantitative way. So there are two ways to define solubility: qualitative way and quantitative way. Now again we have to differentiate between these two terms, qualitative and quantitative. So what is qualitative and what is the mean by quantitative? So quantitative, the term quantitative, remember that the term quantitative always explains through the numbers. The quantitative term always gets explained through the numbers, but the qualitative term gets explained through the inequality. So for example, you are a student. So if I say the student is bright, that indicates the quality. That indicates the quality. But if I say student is so bright that he gets or he scores more than 90% marks always. So here is a quantity. So quality is bright, but quantity, he is so bright that he is getting more than 90% marks. So that is a quantity. So likewise, solubility can be defined in two ways. One is a quantitative way and another is a qualitative way. So in quantitative way, we will see the term amount, but in qualitative way, we will not see this term amount. So definition of solubility in quantitative way. So in quantitative way, solubility can be defined as the amount of solute required to form a saturated solution in given amount of solvent at a certain temperature. So again, in quantitative way, solubility can be defined as the amount of solute. So here is the amount of solute required to form a saturated solution. Now here is the term called as a saturated solution. Later on we will see this term saturated solution in given amount of solvent. So here is the quantity of solute as well as quantity of solvent is given. So the quantitative way, solubility can be defined as the amount of solute required to form a saturated solution in given amount of solvent. That is a quantitative way definition of solubility. And another way, qualitative way. So qualitative way, solubility can be defined as a spontaneous interaction between solute and solvent to form a homogeneous solution. Solute and solvent solute and solvent will undergo a spontaneous process to form a homogeneous solution, that is called as a solubility. So here in this term you will not see any quantitative terms like amount. Here is only, it indicates the quality. That quality, what kind of quality? So quality of formation of homogeneous solution. So solute and solvent are getting mixed together to form a homogeneous solution is nothing but a solubility. But amount of solute and amount of solvent are getting mixed together to form a solution is nothing but a solubility definition by the quantitative way. Then next we will see these three terms which are the basics of which are the basics of solubility: solute, solvent, and solution. So first I will give an example, then we will move toward this term solute, solvent, and solution. So for example, take an example of sugar in water, solubilizing sugar in water. So in this case, sugar will act as a solute while water will act as a solvent, and by combination of this solute and solvent we will get a solution. So what is the exact definition of solute and solvent and solution? So solute, the substance which gets dissolved in solvent, is called as a solute. For example, sodium chloride or sugar. Solvent, the substance in which solute dissolves, is called as a solvent. For example, water or ethanol. And solution is nothing but a homogeneous mixture of solute and solvent. For example, solution of sugar in water. So don't get confused between these two terms, solute and solvent. So solute, remember that solute is a substance which gets dissolved, while solvent is a substance in which solute dissolves. Don't interchange these two terms. Solute, the substance which gets dissolved. Solvent is the substance in which solute gets dissolved. For example, sugar in water. So sugar is solute while water is a solvent. Sugar is a solute while water is a solvent, and the combination of both these two will give the homogeneous solution, homogeneous mixture. That homogeneous mixture is nothing but a solution. So here is the simple diagrammatic representation of solute, solvent, and solution. So solute, this is solute, this is solvent, and after combination of these both two, we will get a homogeneous mixture which will be called as a solution. So I hope that you are now clear with the term solute, solvent, and solution. Try to remember these terms through an example. Take a simple example of sugar in water. So sugar is a solute, water is a solvent, and the mixture of sugar and water is nothing but a solution. Simple one. Then we will move toward the types of solution. Solutions can be classified in two types. One is depending upon the amount of solute present in the solvent, and second is the depending upon the state of solute and solvent. So depending upon the amount of solute present in the solvent, so how much amount of solute is present in given amount of solvent, that will classify the solutions in one way. And another way, what is the state of matter of solute and what is the state of matter of solvent, will again give you the different types of solution. So states of matter, there are three states of matter: solid, liquid, and gas. If you are mixing liquid in liquid, that is one type of solution. If you are mixing solid in liquid, that is one type of solution. So depending upon that, these states of matter of solute and solvent, solutions are again classified. So first we will see the classification of solutions depending upon the amount of solute present in the solvent. So depending upon the amount of solute present in the solvent, the solutions are basically classified into three types. One is a saturated solution, another one is an unsaturated solution, and third one is a supersaturated solution. Remember these terms: saturated solution, unsaturated solution, and supersaturated solution. I am again repeating: saturated, unsaturated, and supersaturated solutions. So what is saturated solutions? So saturated solution may be defined as the solution which contains maximum amount of dissolved solute at definite temperature. Saturated solution may be defined as a solution which contains maximum amount of dissolved solute at definite temperature. Now here is the term temperature. So in our next lectures we will see what is the importance of temperature while studying the solubility. Temperature is mentioned in the definitions of solubility also, and in the definition of solution, saturated solution also. So definitely there is the importance of temperature in the solutions. In the next lecture we will see what is the importance of that temperature in case of solutions. So saturated solution may be defined as a solution which contains maximum amount of dissolved solute in definite temperature, or in another term we can say saturated solution is the solution where the solubilizing power of solvent is full. The solubilizing power of solvent is full. So solvent will not dissolve more amount of solute beyond this point. Unsaturated solution. So unsaturated solution is defined as a solution which contains amount of solute less than the saturated solution. So saturated solution is the solution where the maximum amount of solute is present in the solvent, and unsaturated solution is the solution where the amount of solute is less than the saturated solution, and opposite to that is a supersaturated solution. So supersaturated solution is the solution where the amount of solute present in the solution is more than the saturated solution. So supersaturated solution contains more amount of solvent than saturated solution. So here one simple question arises in our mind, that in case of saturated solution the solubilizing capacity of solvent is over, then how we can dissolve more amount of solute than the solubilizing capacity of that solvent to form a supersaturated solution. So by increasing the temperature of the solution we can dissolve some more amount of solute in that given solvent. Saturated solution is there. If we heat saturated solution little bit and we add more amount of solute to that, that solute will get dissolved in that solvent. So we will get a supersaturated solution. So these are the three types of solution depending upon the amount of solute present in the solvent: saturated, unsaturated and supersaturated solution. I will try to explain this term by taking a simple example of bus. So consider a bus which is having capacity of 10 seats. Consider a bus which is having capacity of 10 seats, and that bus, the number of passengers sitting in that bus are 10. So in this case all the seats of the bus are occupied. Hence we can call this condition as saturated condition. We can call this condition as saturated condition. In second case, consider that the capacity of sitting capacity of bus is 10, but only 7 passengers are sitting inside the bus. So 3 seats are empty. So in that case the bus is not full, and that will be called as a unsaturated state. That will be called as a unsaturated state. And suppose in third case the sitting capacity of bus is 10 seats and in that bus 10 passengers are in the sitting condition and plus 2 passengers are in standing condition. So bus is now overloaded. Actually the capacity of bus is only 10, but the bus is now carrying the 12 passengers, more than the capacity of that bus. So such condition will be called as a supersaturated condition. Such condition will be called as a supersaturated condition. Simply this analogy can be applied to the solute and solvent, and upon depending upon that we will get you will understand what is the saturated solution, what is the unsaturated solution, and what is the supersaturated solution. Remember the word capacity. Capacity of solute, capacity of solvent to solubilize the solute is full, then it is called as a saturated solution. If capacity of solvent is not full, then it is called as unsaturated solution. And if the amount of solute dissolved in the given amount of solvent is more than the capacity of the solvent, then it will be called as a supersaturated solutions. So these are the three types of solutions depending upon the amount of solute present in the solvent: saturated, unsaturated, and supersaturated. Then this is the diagrammatic illustration of unsaturated, supersaturated, saturated, and supersaturated solutions. So these are the three solutions present in the test tube. This is first, this is second, and this is third. So this arrow indicates that concentration is increasing as we move towards as we move from unsaturated solution to the supersaturated solutions. So in case of unsaturated solutions, more solute can be dissolved. In case of saturated solution, the capacity of solvent is over, so we cannot dissolve more amount of solute. And in case of supersaturated solution, by applying heat, we can dissolve more amount of solute inside the solvent. That is called as a supersaturated solutions. But this solution, as obviously is we have applied the heat to dissolve the more amount of solute, but if the temperature of that solution decreases, or that solution comes at room temperature, then obviously the excess amount of solute which was dissolved in the solvent will get precipitated out in the form of crystal. So temperature must be increased in order to form a supersaturated solution. Next, classification of solution depending upon the state of solute and solvent. As obviously I have shown you that different states of matter are liquid, solid, and gas. So depending upon the which type of states of solute dissolves in which type of state of solvent, there are generally 9 types of solution. So gas in gas, first type of solution is a gas in gas. So one of the simple example of this gas in gas solution is air. Okay, the atmospheric air which is present around you, which is present around us, is the simple example of a solution of gas in gas. So this is the mixture. Air is the mixture of gases, different types of gases like nitrogen, oxygen, carbon dioxide. These are the gases which are present altogether in the form of air. So obviously the amount of nitrogen is more in the air and amount of oxygen is less. So we will treat here nitrogen as a solvent and oxygen as a solute. So oxygen is dispersed in the nitrogen, hence we will treat the air which is present around us as a gas in gas type of solution, as a gas in gas type of a solution. Then next, this is the first gas in gas. Next, gas in liquid. Gas in liquid. Can anybody remember or can anybody recall the gas in liquid type example of solution? I think everybody must have seen this gas in liquid type of solutions. Must have instead of saying seen, I may say that must have consumed this gas in liquid type of solutions. So simply the example is a soda. Okay, so or carbonated drinks like Coca-Cola, Pepsi. These are the carbonated drinks where gas, carbon dioxide, is dissolved in water. Where gas, carbon dioxide, dissolved in water. Remember that when you open the bottle of carbon dioxide, when you open the bottle of Pepsi or Coca-Cola, there is a fizz, sound of fizz at the time of opening of the bottle. So that sound of fizz is nothing but a carbon dioxide getting released from that bottle. Okay, so the carbon dioxide in water is an example of gas in liquid. So here we will see it is a liquid, and in this diagram or in this image you can clearly see that carbon dioxide is getting released, or the gas is getting released from the liquid. So simply if you put the Coca-Cola or Pepsi in the glass, you will see, or Sprite in the glass, you will see the bubbles are coming out of that Coca-Cola or Pepsi or Sprite. So these bubbles are nothing but bubbles of carbon dioxide, and these bubbles are dissolved with the help of high pressure. So this is another important factor, as we have seen in previous slide, temperature, importance of temperature is there in the solubility, like importance of pressure is also in the solubility. So by use of high pressure, the carbon dioxide is dissolved in the water. So this is another, the second type of solution, gas in liquid. Then next, gas in solid. So gases in magma. Magma means the volcanic eruption. Magma is released by the volcanic eruptions. Volcano releases the magma, and that magma contains various types of gases like water vapor, carbon dioxide, sulfur dioxide, and hydrogen sulfide. Okay, so this magma you are seeing here, this magma is actually contains various types of gases. So this magma will be will you will see this magma in solid state after drying, and that magma contains gases like carbon dioxide, sulfur dioxide, and hydrogen sulfide. This is the third example of solution depending on the type of state of solute and solvent, that is gas in solid. Then next is a liquid in gas. Liquid in gas. So it is also a very simple example of liquid in gas type of a solution. So water vapor in air. So if you heat the water, that water will get converted into the vapor, and that vapor will mix with the air. That is the simple example of liquid in gas type of a solution. Liquid in gas type of a solution. So water is a liquid. Okay, water is in liquid form, and that liquid water will get vaporized, and that vapors will mix with the atmospheric air. That is nothing but a liquid in gas form of a solution. Then liquid in liquid form of a solution. So this is again a simple type of solution, liquid in liquid type of solution. So both the solute as well as solvent is in the liquid state. So simple example is ethanol in water. Simple example is ethanol in water. So ethanol, when mixed with water, you will not differentiate, or you will not be able to differentiate between in the solution which is ethanol and which is water. So mixture of ethanol in water is the simple mixture of liquid in liquid. Also mixture of benzene and toluene. Mixture of benzene and toluene is another example of liquid in liquid type of solution. Water and ethanol, benzene and toluene, liquid in liquid type of solution. Then liquid in solid type of solution. So here solute is liquid and solvent is solid. So sometimes it might be weird to think solid as a solvent. Generally we will think, when I say solvent, generally you will think solvent is always in a liquid state, and when I say solute, you will think that solute is always in a solid state, but that is not the case. Liquid can be a solute and solvent can be a solvent. So solid can act as a solvent while liquid can act as a solute, but general perception is that the liquid will always act as a solvent, but it is not like that. So liquid in solid, example is mercury in silver. So mercury is, which is a shiny metal, okay, which is a shiny liquid metal, will get dissolved in a silver. Silver is again a solid metal. So mercury in silver will form a amalgam, and that amalgam is generally used to fill a dental caries. That is called as a dental amalgam. So here is a mercury, okay, and in that mercury, which is in a liquid state, can be incorporated in a silver to form a amalgam. It will form a amalgam, and that is an example of liquid in solid. Then solid in gas. Solid in gas, so solid will act as a solute and gas will act as a solvent. Solid will act as a solute and gas will act as a solvent. So example is iodine vapors in air. Iodine vapors in air is an example of solid in gas. Or another example we can say camphor vapors in the air. So you take a camphor, keep it at a room temperature. Keep it at a room temperature. So after some time you will see that camphor gets evaporated, and that your vapors of the camphors are now getting mixed with the air. So that is the example of solid in gas or iodine vapors in gas. So this is the iodine, and these are the iodine vapors which are getting mixed with the gas. So here iodine act as a solute while gas act as a solvent. Then next type of solution is solid in liquid. Next type of solution is solid in liquid. So what is the example of solid in liquid? Can anybody tell? Solid in liquid, simple example is sugar or salt in water. We will mix sugar in water or salt in water. That is one of the simplest example of solid in liquid. So household, you can try immediately after this video, take some sugar and add in water, or take some salt and add in water and simply stir. What will happen? That sugar will get dissolved in a water. So in this case, sugar is acting as a solute which is in a solid state, and water will act as a solvent which is in a liquid state. So sugar and salt in a water will give you the solution which is solid in liquid type of solution. Then solid in solid type of solution. So solids can be mixed with another solids to form solutions, and these solutions are generally called as alloys. Solids can be mixed with another type of solids, where one solid acts as a solute and another solid acts as a solute, and another solid acts as a solvent, and this forms a solution, and this solution is called as a alloys. The solution is called as a alloy. So you must have heard about the alloys. So alloy is a combination of elements in solid solution with overall metallic properties. So here you can see this is one type of metal, and in the yellow there is another type of metal. In the purple there is one type of metal, in the yellow there is another type of metal, and that one type of metal is mixed with another type of metal. So one solid is mixed with the another solid to form an alloy. And these are some examples of alloys like steel, bronze, brass. These are the examples of alloys or solid in solid type of solution. These are the examples of alloys or solid in solid type of solutions. So these were the different types of solution. Again we will see fast forward the different types of solution. So gas in gas, example is air. Gas in liquid, example is carbon dioxide in water. Then gas in solid, example is gases present in magma. Then liquid in gas, example is the water vapor present in air. Then liquid in liquid, example is ethanol in water, mixture of ethanol in water or mixture of benzene and toluene. Then liquid in solid, example is mercury in silver, which we called as a amalgam. It is called as a amalgam, mercury in silver. Then solid in gas, example is iodine vapors in the air. Solid in gas, example is iodine vapors in air. Then solid in liquid, simple example is sugar or salt in water. Then solid in solid, example is alloys. So this was about the basics of solubility, definition of solubility, what is quantitative definition of solubility, what is qualitative definition of solubility, what mean by solute, what mean by solvent, and what mean by solution with examples. Then we have seen different types of solution, two types of solution, two types of classification of solution. One classification is based upon the amount of solute present in the solvent, which gives you the three types of solutions: saturated, unsaturated, and supersaturated. And another type of solution which is based upon the state of matter of solute and solvent. So there are three states of matter of solute, states of matter: solid, liquid, and gas. By making the combination of these three states, we can get a 9 types of solution: solid in gas in solid, gas in liquid, gas in gas, then liquid in solid, liquid in liquid, liquid in gas, and solid in gas, solid in liquid, and solid in solid. So these are the 9 types of solutions. So I hope that you must have understood these concepts. If you have any doubt, please write in comments. I will be happy to solve your doubts. Also, please subscribe to my channel so that you will get more and more such types of videos on the different topics related to the science. So please subscribe, do subscribe to the channel, and also ask your friends to subscribe the channel. So as we have seen this concept of solubility, basics of solubility, we will move towards the multiple choice questions. So first question is, solution containing more amount of solute than its solubilizing capacity is called as. So the options are saturated solution, supersaturated solution, unsaturated solution, and real solution. So write down the answer. So saturated solution, supersaturated solution, or unsaturated solution. So the question is, the solution has solvent has more amount of solute than its capacity, and we have seen that the solvent which contains more amount of solute than its solubilizing power is called as a, yes, correct, supersaturated solution is called as a supersaturated solution. So saturated solution, the solubilizing capacity is full. Unsaturated solution, solubilizing capacity is not full, that is the less amount of solute is dissolved. And in case of supersaturated solution, more amount of solute is dissolved than the solubilizing capacity. That kind of solution is called as supersaturated solution. The fourth one is a real solution, which we will see in the next lectures. So the answer is supersaturated solution. Next type of next multiple choice question. Example of liquid in solid solution is: the first, ethanol in water, salt in water, carbon dioxide in water, third option, and last option is mercury in silver. So here liquid in solid means liquid is a solute while solid is a solvent. So ethanol in water, first option, ethanol in water. So ethanol obviously in a liquid state, water is also in a liquid state, so it is a liquid in liquid type of solution. Then salt in water, so salt is in a solid state, water is in a liquid state, so it is a solid in liquid type of solution. Third option, carbon dioxide in water, where carbon dioxide is a gaseous state, water in a liquid state, so it is a gas in liquid type of solution. And last option is a mercury in silver. So mercury is obviously a liquid and silver is a solid, so it is a liquid in solid type of solution. So the correct answer is D, that is mercury in silver. So please do subscribe to my channel, and thank you very much for watching.